What would happen if everyone on Earth aimed a laser at the same point? Let's start with a 5 milliwatt laser pointer. This is the kind teachers often use during lectures. Now imagine all 8.2 billion people on Earth, each holding such a laser pointer and aiming at the same spot. That would be a total of 41 megawatts. Sounds impressive, but because this type of laser has a wide divergence angle, by the time the beams reach the target, the spot is already 15 meters across. The power is greatly weakened. So, what happens if we all aim at a piece of paper? As you can see, nothing happens. The paper doesn't even get scorched. It just turns bright red under the cover of light. What if we increase the power? All right, let's switch to a 1-watt blue laser pointer. This kind already has some destructive ability. It can ignite paper, and if it shines into someone's eyes, it can cause blindness. So, for safety, we'll need protective goggles. With 8.2 billion people, that's 82 terawatts in total. Roughly the power consumption of a major city. And since this laser has a smaller divergence, the spot at the target is only about 1 meter wide. Now let's see what happens. This time it works. The paper bursts into flames easily. If aimed at metal, it can even melt a small patch. But to blast through an entire mountain behind it, the energy is still far from enough. So what if we keep increasing the power? Let's use a military-grade weapon next. These lasers can reach 100 kilowatts, powerful enough to shoot down drones. Their energy density is extremely high, with a spot only 5 centimeters across. Now what happens if all are aimed at a sheet of paper? The paper instantly vaporizes. Metal melts. Within minutes, the ground itself is burning and a deep hole is formed. And if aimed at a mountain? At first, an ultra-hot spot appears. The rock begins to melt, and over time, the melting penetrates deeper and deeper. The laser works like an energy drill, burning through layers of rock and eventually leaving a tunnel in the mountain. But the process would take weeks. Is there an even stronger laser? Here comes the ultimate weapon, a 1 megawatt laser. This kind is designed to defend against missiles. With 8.2 billion people, that's 82,000 exawatts, more than the total global electricity consumption. Now let's see if the mountain can withstand it. At the target point, the rock instantly vaporizes and ionizes, forming a plasma fireball. The rock no longer melts slowly, it explodes rapidly. The entire mountain is blasted through in no time. The energy is so great it even ionizes the air, though that reduces the laser's power somewhat. Still, nothing can stop it from drilling through the entire mountain range with